start this. Bildschirmfreigabe. Freigeben. So, let's continue on our string class and add some more functionality to it. So we already have search and find, so find and reverse find. I think the next things that might be useful to add would be let's see. We have here a test. Would be functions to replace a string with another string, so that you can. So if you have a string, then you can say replace every occurrence of something with it. So, and the other function type that would be quite useful would be something to break the string apart into substring based on some separator. So this is called tokenization of a string. You specify a token which acts as a separator, and then what you get as an output are substrings which contains only the string portion between two of the tokens, or between the end of and one of the tokens. So an example, sorry, we're gonna call this function split string, and the example of that. So when we start with 1, 2, 3 space 4, 5, 6 space 7, 8, 9, then this will give us then a couple of strings. 1, 2, 3, comma 4, 5, 6, comma 7, 8, 9. And what I found also extremely useful often is something that works like this split string, but only splits it once. So which does it split and split once, which would then take the same arguments as the normal example, but it would provide just a pair of output variables. And what would be also good would be a reverse split once, R split once, which would work like this. So this type of functions are very useful if you are passing some sort of text data, because, for example, if you know that some prefix will always occur, then and then will be followed by a separator. For example, if you have a URL, so real world example. Something like that. So you could use, for example, split once, comma Doppelpunkt, and then you would get as a result the protocol, which might be different, might be HTTPS or FTP or any of the others, and then the actually that can be more detailed. Or you can get the whole path. Wait, no, that's not good. I'm missing this. And once you have the path, I mean, this can also have like a subdomain. So from this you can use again split once with a slash to get the domain, and then the actual path. Then you could use reverse split just to be on the safe side. Well, it doesn't matter. You can use any of the splits to get the path as such, and then the query. Oops. And so on. So and then of course you could, for example, split this apart in the individual parameters. If you split use, for example, our split many, and then you just get all the parameters split, and then each of them, if each of these parameters you can then again split with a split once here, and using a split once function will of course be also more efficient, since as soon as you find your separator, you then just you are done, you can just return the result. So let's start. What of those would be more interesting? So one, of course, thing to notice that if you have implemented split, then you could in principle always use split and then just merge everything that's the result to create your split once and R split once. But of course this would be then rather inefficient, so we don't want to do that. Maybe one more thing that we would want to add would be a join function that takes multiple strings. First it takes a count, then it takes all the different strings and merges them. So it takes two things. It takes an optional string for to put in between the strings when it merges them. So in this case, or let's do a better example. Let's use a minus so that we actually see that it works differently. So then takes the count, and then it takes as a variable as a vararg function the different individual strings, such that we can then merge them together. In advanced frameworks like Qt, for example, you have a dedicated string list class. So if you split a string, you get as a result not just a general list but a string list of those strings, which is just of course derived from a normal list. But then this string list offers you a join function, which then just takes only the new optional separator as an argument. But since we here don't have haven't wrote the whole framework, just one string class, I think the approach with a vararg function is reasonably good. Of course, the function, the join function as such, does not need to be defined on the string object, since it just returns a new string. It can be a static function or just a global function. We will just define this one as a static function on the string. That was the T. A static function on the string to keep it in the string namespace. So who would want to start with one of those functions? Any volunteers? Okay, so let's maybe start with something easy. Let's start with the search and replace. So we have a search function. We need now a replace. In principle, we could add a replace once function, or we could to the replace function add a counter. I think that would be most elegant. So the replace function with the arguments, let me just quickly write the arguments, will be find place and max and -1. So the first argument is what string to replace with which string, and then a max count, so how often to replace, and if it's -1, then just replace all the occurrences that are found. This seems most efficient, and from the implementation will also be quite fast. No problem. Yeah, it was almost a month. 3 weeks. So this maybe I should also say the function is supposed to return a new string and don't alter the string on which it was executed. In Qt this is different. Qt actually alters the string itself, which I find quite annoying to be honest. I would find it better if they would have made the replace work on a and return a copy. Of course, it's quite easy to work around such a limitation. You just make a copy of the string and then run the replace on that. And this you can do in one line if you just write qstring brackets, then the old string close brackets dot replace. Mm-hmm. Yes. Well, if you would write this find, so this arrow find, then it would have worked. But it's also always better to. Also, you probably should then call the second argument replaced as well, just to be on the safe side. Yeah. Well, you are now looking probably towards like making a copy of the string, finding the occurrence, replacing it, then having the whole new string, and then searching again and searching again, and then each time taking the two parts, replacing the in between, and recreating the whole string multiple times, right? That's that will get inefficient the more occurrences you have. So ideally, we would want to rebuild the string only once. So this so the strategy should be like this: you have a loop, you find the first occurrence of what you want to replace, then you copy the portion of what you have now. Then you copy the portion that you know is fine without occurrences to the new string. Then you insert the replace string if there is any, and then you search again for the next occurrence. So then you take the next portion of the string, add to your total string, add the next replace string, and then search for the next, and repeat that until you reach the end of the string. So with such non-trivial loops, I find it always most useful to just make an infinite loop and then write inside the loop my break and continue conditions. And then if I see that everything works as expected, then if it is expedient, refactor the loop to something that uses less lines of code. Yeah, and the fastest sort of loop is one like this. Although I think the modern compilers, if you make if you make a while one, will probably just optimize away the check if one is one. But like super old compilers from the DOS ages without optimizations, they actually then would just compile the useless check in and waste CPU cycles. But I guess nowadays compilers are quite good. Well, you can just create a normal new string of type cx string, and then start adding. I think we already have an append function, don't we? I think it would. I know I'm giving many advice, but I think that it would be most efficient if your new string would just start out empty, and then you just add those portions that you find in this. Yeah. Yes. Well. Mm-hmm. Yes. Mm-hmm. I think -1. One thing that, for example, is done in the STL template library is that they actually defined a npos value on their string, which just contains the number -1. But it's like more. If you read the code, then and see a string double point and double point npos, that already tells you that probably it's something, not just a number, because if you have -1, then it might be ambiguous if you don't know how those things are supposed to operate. But if you see that you get the endpost, then it helps. So we could, if we want, also define such a const variable on our string as well. Hmm? Well, if you put in last find, then it will find the same thing again and again and again, and you will have an endless loop. But if you put find +1, then the behavior, if we have no, because what we are searching for might be more than one string. We might search for a word there, for a word there, or for 3 spaces after each other. So the way it's made now, if we have 4 spaces, it would find the first 3 spaces, replace the first 3 spaces with the string, and then skip by 1, search again. From the 4 spaces would be still 3 spaces left, so then it would replace again. So we would end up with having replaced 4 spaces with twice our replace string. Yes, exactly. Length. Yeah, but you are right that we need a condition to what to do if it's 0. So you don't want yes, that would be an option. You return the string, you added the replace -1 break. Well, there is one obvious bug. If you break at -1, then the last portion of the string between the last find string and the end of the string will not be added at all. So you need to somehow the end is automatically I think our substring has a default value for the length, which is -1, which means to the end. As I know me, that's the way I would have ordered it to be made. But I also don't remember. Let's check. What our substring does. Find substring. Yeah, length -1, and if it's -1, then take the whole length. So that should be fine. Okay, now we need a test case. Yeah. Okay. I just noticed one other bug. We ignored the max argument, but that can be added later. Okay, it doesn't like something. You use the same string twice. You could call the first one new string, for example, or something like that. Yeah. Yes, it does. Well, it never breaks. Well, it will, because your trinary function checks if last find is 0. Okay, but then it should change last find to index. Not that I don't know why it doesn't work. Let's try it. Just put a breakpoint somewhere and step through the code. It's not apparently apparent what's wrong. Oh yes, I know what's the problem. If it's the first occurrence, then the last find after line 180. Yes. No, there is an easier fix. You, instead of using the trinary operator at the top, you could just edit line 192. No, sorry, 187, and there add index plus fin string length, and that takes care of only adding it after the first iteration. Not longer needed. It won't compile. You need to replace the variable name in line 180. Yeah. That seemed to have worked. Perfect. That is not cool. No, that's right, because your replace string is 1 to 3. You would want it to change test. Yeah, when it's the last one. Oh, interesting. Go to the call stack and see from where the... I guess it will repeat itself, yes. Go to the call stack and see where... Click. Substring. Last find. Is our substring returning null sometimes? Perhaps it is. If it's an empty. No, it returns. I think it returns a string, but the string is empty, and our append does not check whether it works. It should be length, but this is it has a t too much in it. Well, you could just make if last find is... Well, last find will be the last occurrence in the string. But last find will be... Well, first thing to do would be probably it would be good to have this code inside the if index is -1 break and then break, not after the loop, although this doesn't change much. Let me think. Yeah, this should be there, and we can then and then last find, but then that will not change anything. That will just crash the same way. Why did it crash? Because we have last find. Wait. Because we had last find plus length. So maybe leave it where... Yeah, we had last find plus length. No, here it should work. Should it? Because then we go again, and then we don't find it. We still need the additional check. No, that will not work if it's less than length. Because what basically happens is that last find is equal length after line 190, and then the return string by substring is an empty string. But this also means we should fix our append function to not crash in such a scenario. First, you can try whether this works now properly. Yeah, and then we can quickly go to the append function and try to repair it. No, that thing. No. The add string pointer can be null. We need to test if it is null. So if it's null, or you can use it. You could use the same if for that. Just if add string pointer is null, or no, it needs to be the first check. Yeah, that solves that. Yep. Good. Perfect. So now we need another volunteer. Maybe Mr. Leo. Yeah, so how about we try now the split functions. So just the global split that just splits into arbitrary many. Haha, I see a problem. We don't have a list class to return that. Let me quickly think how we fix that. Because we would somehow need to return a list, but we don't have a list object. Yeah, we could use std list. Yeah, let's use that. Yeah. Mm-hmm. std list pointy brackets. No, just list. I think you first need to include it. I think it might not be included yet. We only included atomic. Yeah, and included outside of the if structure, just to always have it at our disposal. Just list. And the type will be cx string. Yes, cx string. We only need one argument that, well, we could add a couple arguments which would then make the split 1 and split 2 obsolete. We could have an argument split at. Okay, split at is fine. We could have an argument max split count. And we could have an argument that tells it to search reverse, but for reverse we'll just make a r split function. And this by default should be -1 because we want to split as often as we can. Yes. And now all the split ones functions can be just well emulated by using by specifying max split 1, which is quite nice. We return a std list x string. Mm-hmm. Yes. Probably not. You can you can insert a new C string into the splitted list in one line. You can just write, well, substring already gives you a new string instance. You can just write splitted punkt pushback, and then your punkt. Why is it not suggesting anything? Bash underscore, yeah? Yep, that should be it. You need two more things, but yes. Split count is also necessary. Also, I just noticed we forgot the max replace count in the other example, so we'll need to add that as well. Mm-hmm. You have the remaining part of the string in line 213. Yes. Well, you need also to have something in line, change something in line 213, because you don't have a new string at all. and you need to return the splitted list somewhere, and we need a test case. Yes. And we need a test case. Yes. We will need to change that in the in the header as well. So yeah, but don't use char. You will need to use the placeholder we have in our template. Yes. Yes. Mm-hmm. And in line 200, you also need to add the template placeholder. It will do an error, but only once you compile it, since it creates those functions really only on compile time. So the error, the IntelliSense errors that show without compiling the code will usually not work very reliably for templates. Yeah. Well, you would need to take into account that your length would need to be one less than the count, since then you still add one more. But it depends on the definition. Let's say if we split once, now then you could use it. Yeah, you can use it. That should be fine. Size. I don't think you need -1, just size. And round brackets. Nope, you need to make a loop for that. Mm-hmm. But you will need some break condition at some point. Also, you cannot use list with indices. You could only do that with a vector. There is also no add function. You could go with begin plus I. That's highly inefficient, but would work, I think. Well, in the list you can no plus one in the begin plus one plus I mean. But I'm not sure if this is implemented. Just try it if the iterator has the plus number operator. Plus I. It does not have the plus operator. So the difference between list and vector is that in a vector, all the elements occupied an adjacent area of memory. So if you have a point at one of them, you can go to the next, to the next, to the next, to the next, etc. With a list in STL, it's a linked list. So you have only a pointer on the first and the last element, and then you can from each element just go one step, next step, next step. You cannot address them, the content of the list in the middle, arbitrarily, which is not. Yes, that would probably be better for the typical use case. Let's go with the vector. With Qt it is different. Qt allows you to access list elements at an arbitrary index as well. I don't remember how they implemented that internally, if they have just a lookup table or if they internally have implemented it as a vector. Yeah, here as well. Line 200. That should also work on vectors. I think pushback is defined on all the linear containers. What would not work would be push front, I think, because a push front in vector would mean that they need to really move the whole memory. But they might have added it later. I know in the very old versions of STL, push front was not available. And then now you can just use the square brackets. But they might have added it, because in principle there is a valid case why you would want to add something to the beginning of a vector, and how to do it is quite easy. You just have to shift all the whole memory block by one. You need to make yeah, exactly. Okay, we should probably also print some other characters such that we see where it's split, like, I don't know, a space or a minus sign or something, or a new line such that we get one entry per line. That would also be fine. The vector has a size variable which tells you how many elements it has, and you can put it into the for loop in line 79 directly. Mm-hmm. Let's roll. That did not print anything. You can put a breakpoint there and see if it actually added anything into the list. Four elements. That should. Oh right. The check is wrong. I don't know why in the German keyboard they put the two keys, the two arrows on one key with a shift. They should have added them. For example, two keys 6 and Shift S or something. Okay, Shift S is used for something else. But they should add it somewhere, like maybe keys 5 and 6 with an Alt key. Ah, that's not good. Yes. It has to be less. It works. Very good. So let's take a look at the function again. Yes, what we can. Yeah, we should test this as well. Just use one, because that's the pretty much the two major use cases will be one or infinite. All the other use cases will be very rare, but I guess it will be nice to have it if one has it. Okay, cool. So now what we need. No, we don't have infinite. Well, yeah, we can use it. That evaluates to -1, but like it would not be probably ideal to take. That actually might not work. Well, it will work in practice. You can check the definition of infinite if you shift or like this. So this is only this would evaluate to -1, but only in 32-bit. If you have 64-bit or use size T, then this would not be like -1, but this would be then well, just 4 billion. But I guess there will not be no realistic strings where you have 4 billion entries, so I guess we are on the safe side here. So we can leave it as is. Yeah, and the next when we look at the function again, let's see if there's anything we can improve on it. That looks, in principle, it's fine. One could try to reduce the amount of ifs to 1 down, but then we would still have a find which we don't need, which would be wasteful. So let's stay with it as is. Okay, and one more thing, what we need is the reverse split function, which splits the string, but starting at the back. And at this at that opportunity, we will find out if there is a push front at the vector. Because we want to still maintain the same order, but we want to start the splitting from the back. So yeah, we need. Yes, please. Yes, please. I think we have. Yes, it should run basically everything in reverse. Yeah, we have length. Well, I guess probably line 246 might also need to be changed, because we then would always want to go in the other direction, so we don't want to add split add, and I guess probably if it's made without too much testing, it will result in substrings. You need more changes. Substring is also wrong, because substring takes the index from where to operate and then goes to the end, but we want to go to the beginning of the string, so we would need to have substring 0, last find and things like that. There are quite a few things that you need to change to make this properly work in reverse. It will take the string from last find till the end of the string, but what you want to do here is you want to take the string from 0 till last find. So substring must be defined as 0, last find. Yes. Also check what does R find returns when it doesn't find anything. I'm not sure if it's still -1. Maybe we said that it then returns 0. No, it's still -1. Okay, at least that one is fine. If you are in doubt, you can always run the code and see what it's doing. There is no push front. Since we don't have a push front, there might be some other option to insert it, but I would just go with using a list here. Or let me think. May I have the mouse for a second? What do we have? Do we have a? We have an inset. We have an inset. We have an inset. Inset is good. Insert. Yeah, you can do that as well. But I think that this would probably also work. inefficient, but it should work. You can try if it, because we had this. Let's see. We had this 3 times, so let's see if we replace them, if it will then compile. Okay. We have another error. Okay, this substring is definitely wrong. You need to fix that. But wait, and I think the subsequent error is just because the first error occurred. So first you need to fix the substring invocation, and then we can see. But I think this insert should work okay. I mean, it's not super efficient because it then copies the whole vector again, but our vectors will be very small since our CX string only holds a pointer and that's it. So that should, with regard to the efficiency, be acceptable. Yeah. Maybe, we will see. No, I think it should be just nothing, just the last find like index. In the list, you should, in the vector, you should be able to. It's empty. It does not contain anything, I think. Yeah, now it should contain something. Oh, actually, it should have contained something because it says size 2. You can open this, yes, and then you see the entry. So you have one entry. This one said write test, and the other one is an empty string. Why do we have an empty string in it? No, that would, it would either crash or do what we want it to. You can run it again from scratch, or put a breakpoint on every of the inserts. That's the best thing. Click. Okay, now stop and run, or yeah, or use the one button that does both. Okay, so now size is 0, so it's fine. And if we now make one step, it has size 1, so we can open split it, and the entry is null. So the substring is wrong. Substring is giving you an empty string, and then an empty string is being inserted into the list. Yeah, that's for you to figure out. Index is there. Maybe we will see. Okay, what do we got? Quite not right yet. No, but that's still not. That still would not give you. So what what are we splitting at? What's our split string? Space. Yeah, but if we are going from the back, then we should only get 1 to 3 into the string. So it's definitely more than a -1. And minus, I don't know, 7 is probably not right. So we need to find out which values would be the right ones. So first of all, you need to find out at which index the last 1 to 3 starts. So if you search from the back, then your now the code is gone. Can you switch? Okay, yeah, you can count it. Well, in the first loop, it will be the content of the edx variable. D. You can switch the hex display off. It's not 0, it's 000D. And D is 12? No, wait. A is 10, 11, 13. Yeah, that's fine, that's the right value. So this must be what you pass as the index where you want substring to start copying. So your first argument of substring should just be edx. Or maybe edx plus 1. Yeah, definitely edx plus 1. Actually, no. edx plus length of split add, to be exactly. Yes, because already the first one, but you want where it ends. And then you need to and then second argument from and the second argument of substring is the length you want to copy. Looks correct. You could just rerun the code, and once you reach the first breakpoint, or the second one, check whether what's inside is what you expect it to be. Yeah, okay. The next one didn't work. The next one ended up being empty. Well, I think we hit line 234, then and we are still at the right stage of the execution, so you can inspect the index and last find and try to deduce why probably last find minus index ended up being 0. Is that possible? 13 and index is 13, yes. Oh, we have an endless loop. Yes, you need to... What do you need to do? You need to make it minus split at length. Yeah. No, not here. I mean in line 246. Because now the index is where it wants, and then it always starts searching. But that should not have worked. No. I think our rfind might have a bug, because normally, may I have the mouse shortly? Okay, so where's our test case? So this is our string. So if we execute the loop once, so first iteration, then index should be pointing at this. And it's just 1 in length. If that would be longer than 1, it would work. Because if it would be longer than 1, you would want to match something like, well, more than one thing, but that would be already the end of our matching position, so it wouldn't match. But if it's exactly 1, then the next loop will match. So we just need here -1. Then last find will be pointing here, and then it will no longer be able to match with the space or anything that's there. Yeah, okay, that should work. Let's try it. You can rerun the example. Now we need to make one step, and let's see what's in splitted. Yeah, that looks good. Yeah. Okay, then just let it run without a breakpoint, and let's see if that's the point. We don't want this. Yes, we want it to be gone. What do you mean? Try it. Well, yeah, it will disappear. Then you will have spaces and 1, 2, 3 in your string. Yes, the character or the sequence of characters which you are using to tokenize your string should be removed from the result. The windows on the bottom right. It didn't work, right? Apparently we have a problem when what's to be searched for is more than one character long. Or are we printing something extra? Ah. Yes. Okay, so now let's try. Wait, te is missing a letter and one character. That should be test. So our condition, well, in the if with the break condition we have a offset error. We need to add the +1 somewhere. Yeah, because we have here index -1 and then it's the last, so we need to, in line 233 and 240, add last find +1. But this might also, the last find will be 0 +1. And in line 233 we have they are the same break condition, or well, not the same break condition, but the same function where we return the remainder of the string. Okay. Okay. And now try to run it with test, or maybe even with test space, because we don't want spaces in our resulting string. That's not good. It should only return 123 123. So somewhere is still a mistake in the code. Well, without it we had an endless loop, so you need to run the code and step through the code and find out which value is wrong when. Click. What's index? Index -1. Why? May I have the mouse? So last find is 8, and split at is this, and what is this? And this. This is 8, so rfind should return something, because well, I think the bug is in rfind that it does not work if the first if what it is to be returned starts at the very beginning of the string. So we would need to fix rfind, but since we are running out of time, I would say for during the next lecture we will try to debug that further. So we will try to fix rfind and make a few more edge test cases for both split functions to be sure that it is doing what we want, and that's it. And then we will implement the join function and whatever else we can come up with. So that was it for now. We will see each other in a couple hours for the lecture, and yeah, that's it. Or are there any questions?
So I had presented for quite some time. I think I should present next time, right?
Yeah.
And one more question regarding the tensor.
Mm-hmm. Yeah, that's also fine. It's fine. As long as as long as it works, it's fine.
Okay.
Actually, I did it in the same way. I had the same question.
You're right. Ah, sorry. Is that? Yeah, because
Yeah, the counter was that
okay.
Mm-hmm.
Okay.
Yep. Good. Then let's see each other in 3.5 hours from now. Bye bye.
Yeah.